This is the first video in the SQL Advanced series. In this video we take a look at equi-joins, one-sided outer joins, and full outer joins. If you want to work along with the exercises, you will need an Oracle account with the student teams database installed. We won't work with the HR schema in this particular video. You can get the script for creating the student teams database at the URL presented here, shown on the slide. So let's look at one-sided outer joins. When you join two tables in a query, by default, you get output for data that has related data in both tables. And this is called an equi-join. We've seen an example of this when we're working with the student teams database. In the graphic shown here, the output on the left is based on one table, working with students. The output on the right uses two tables, combining teams with students in order to show team name. And what we see is that the two students without a team drop out of the output on the right-hand side. And that may be correct in terms of whatever you're looking for in terms of output. You just need to be aware that this is an issue in working with SQL. So a one-sided join is a way that you can deal with viewing all the data from a table, even if there's no related data in another table. The output on the left uses an equi-join. Add a right or left as a word in front of the word join and you will get a one-sided outer join. In this example we have in the from clause from teams right join students. That means we will look at all student rows even if they don't have an assigned team. So I'll switch over to SQL Developer and I'll run this query. So we've got the right join students, viewing all data from students even if there's not related data in the teams table. Whether to use the word left or right really just depends on which table you want to get the data from. So left and right used below, we have from teams right join students. We're working with all the rows of data from students. If I change the order in which I list the tables in the from clause, from students left join teams, I'm going to get exactly the same output, but I'm using a left join because I listed students before I listed teams. So it's just based on the order in which you are naming the tables. So let's do a one-sided outer join where we show all the teams and count the number of students in each team. So the output that we see here on the left where we have from teams left join students is we're seeing a list of all the teams. And so we have some teams actually with no students. That's not showing up here, however, because what's coming into play here is we're using count asterisk when we actually need to use count and specify the field where null values might appear. So now we're seeing all the teams in the table for the teams, but we're seeing an accurate count for how many students are in some of these tables. So I'll switch over to SQL Developer and I'll run the first version of this where I'm using count asterisk. Again, notice that I'm doing from teams left join students, which means I want to see all teams even if they don't have students assigned. And I get the output for that, but it looks like I have at least one student on every team. So I have to be careful, and in this situation I need to count the data in a field that might be null in order to get the 0 that should appear for teams that have no students. So we've looked at the one-sided outer join. You also have a thing called a full outer join. And we see the SQL here where we have in the from clause from teams full join students. That means we should see teams even if there's no associated students. We should see students even if there's no associated team. And that's what we get in the output. I'm seeing that here's a student with no team. I'm seeing here's a team with no student. What if we have the question, which teams don't have students assigned? So we're doing a one-sided outer join, and we're eliminating some data because we only want to see data that has a null value for the student. So what we have is the from clause, teams, left join students, because we want to see all teams to start with. Then we put in the criteria where student team ID is null. And so we run that query, and what we see is these are the 4 teams for which there is no associated student. Several years ago, the Oracle DBMS did not support the use of the term join, and so as a result you couldn't use in the from clause left join or right join. But you could still do a one-sided outer join. You did it in the where clause. You would put a plus beside the table in which you expect a null value to occur. So in our variation on the example we've been looking at here, I've got the where clause. I'm joining team ID, the primary key in teams, to student team ID, the foreign key in students. And I'm expecting some null values for student team ID. So I'm seeing teams in my output for which there is no student. In this second example of the plus notation, in the where clause I have team ID with the plus next to it, and then I have student team ID, and what I'm looking at now is the individual student, and if there's no associated team I still see that student. I also have in the sorting, which is the order by clause, I've added descending to reverse the sort order so I can see the null values at the top of the list. So what we've covered in this video is the equi-join, which is the default. You get only data from the 2 tables that have related data in both tables. The one-sided outer join will allow you to see all the data from one table even if there's no related data in the other table. And whether you use left or right simply depends on the order in which you list the tables in the from clause. We've also looked at the full outer join, which will give you all the data from both tables, even if there's no related data. A one-sided outer join using isNull is a way to see data from one table for which there is no related data in the other table. And so our example was to look at teams for which there were no students assigned. We looked at the use of plus notation as an alternative to doing the one-sided outer join, but doing it in the where clause. We also saw the use of descending as a feature or an option in order by to reverse the sort order.